After building the hardware infrastructure and adding the controllers, the next step is to enable the system to interact with the real world. This is the role of the Devices module. All sensors and actuators are added here, through which CeresFlows receives information and manages physical processes. Each device in CeresFlows is an independent software object with its own role, settings, calibrations, history, and protection mechanisms. Regardless of whether it is a temperature sensor, level gauge, pH probe, or pump, the platform works according to the same logic and provides a unified way to manage them. When adding the device model, connection method, role it will perform, and controller to which it is connected are selected. From this moment on, the system knows how to communicate with it, which interface it works on, and how to process the returned data. One of the most important concepts in devices is analytics label. Each device necessarily receives a unique identifier that cannot be changed. Unlike the sensor name, which the user can edit at any time, the analytics label remains permanent and serves as a link between the device and the entire accumulated history. Thus, when replacing the hardware, data, analyses, and statistics are not lost. It is enough for the new sensor to use the same analytics label, and the system will continue the history as if the hardware had never been replaced. The platform also supports devices that measure several different quantities simultaneously. Instead of using them as one common sensor, CeresFlows divides them into separate virtual devices. Thus, one physical module can simultaneously provide temperature, humidity, EC, pH, or other measurements, each of which has its own role, settings, history, and calibration. This allows each measurement to be used independently in automations, analyses, and other modules of the platform. After adding, the device can be tested immediately. The module allows sending requests to the controller and visualizing the received data in real time. This facilitates checking the connection, diagnostics, and initial configuration even before the device is included in the automation. Each device has its own calibration system. Depending on its role, different strategies can be used: linear, multi-point, temperature compensation, and other specialized methods. Calibrations can be exported, stored, and reused, which facilitates hardware replacement and system maintenance. The values obtained from the sensors are not written directly to the database. Before that, they go through several successive stages of processing. The data can be filtered, validated, checked for permissible limits, protected from temporary communication problems, and detection of blocked sensors. If necessary, the system can automatically use the last valid value or a preset backup value so that the execution of automations is not interrupted by a temporary hardware problem. After processing, the data is standardized. Different manufacturers use different units of measurement and formats, but CeresFlows records each group of measurements in only one predefined base unit of measurement. Thus, all distances, volumes, weights, and other quantities are stored in a uniform way regardless of the hardware used. This greatly facilitates analysis, visualization, and conversion to the user's preferred units when displaying information. The basis of this architecture is template. Each device has its own template that describes the method of communication, supported roles, measurements, units of measurement, possible calibrations, and all necessary parameters for operation. Thanks to this architecture, the platform does not need changes in the program code when adding new devices. It is enough to create the appropriate template, and the new hardware immediately becomes part of the ecosystem. Thus, Devices is not just a module for adding sensors. It builds a reliable connection between the physical world and the other subsystems of CeresFlows, ensuring that each measurement reaches them verified, calibrated, standardized, and ready for analysis and automation. Sensors measure the world. Devices turn these measurements into information that CeresFlows can use and trust,